Hello everyone, let's talk about vectors. So, a vector has an initial point and a terminal point. An initial point A and a terminal point B. How do you tell the difference? The arrow points to the terminal point. It's like saying which way are you going? We're going from A to B. So A is the initial point, B is the terminal point. The length is called the magnitude. A vector has both magnitude and direction. You'll probably remember that. Magnitude and direction. Magnitude is the length of the vector, and direction is which way it's facing, which we'll talk about the angles shortly. Most commonly, we use component form to describe vectors. These are less than and greater than signs. They are not parentheses. They look like less than and greater than signs when you write component form. So if I say write the component form of the vector that with initial point -2, 5 and terminal point 3, 7, let's sketch that and see what that looks like. We're basically saying which way is it going. So I'll put a dot at -2, 5. That's about here. Let's see. 1, 2, 3. Yeah, right there. That'll be our initial point. And terminal point is 3, 7. 1, 2, 3. And 7 is up there. Okay, so we're going this way. And I want to know what is the component form of the vector. Component form just describes which way you go. How far left or right do you need to go? If you're at -2 and you want to move to +3, you need to go to the right 5. So our component form will say 5 for the x component. That means go right 5. And then if you're at 5 and you need to go up to 7, you need to go up 2. So we'll say 2 for the y component. The x component means go right 5. The y component means go up 2. So 5, 2 will be the component form of vector u. 5, 2. If vector 3, 7 is sketched with initial point 2, 4, what is the terminal point? All right, let's sketch this as well. So it says initial point is 2, 4. Why can't I? Come on. There you go. Initial point is 2, 4. So 2, 4 is right here. And it says the vector is 3, 7. That means go right 3 and up 7. So from there, I'm going to go right 3, 1, 2, 3, and up 7. 1, 2, 3, 4, 5, 6, 7 is 1 off the page. And the vector we're describing is this. This is right 3, up 7. So that's vector u, right 3, up 7. What is the terminal point? It'd be 5, 11. Now that is an ordered pair. That's a point. That's 5, 11. This is saying go right 3, up 7, starting at 2, 4. So if you go right 3 from +2, that puts you at 5. If you go up 7 from +4, that puts you at 11. So 5, 11 is the terminal point. Sketch representations of vector 2, 3 with initial points. So if you start at 0, 0 and you go right 2, up 3, that puts you right there. That's the vector, 2, 3. Now, if you're talking about the same vector over and over again, what you can realize, hopefully, is that it's always going to look the same. What's going on here? I made it so much worse. Okay, let's try this again. 2, 3 is right here. This vector is the same no matter where you start. So if I group these up, I need to group them. There we go. Okay, 2, 3. You can do the same thing starting at 2, 2. So 2, 2 is right there. You can do the same thing starting at -2, -1. You can do the same thing starting at 1, 4, 1, 4. See how it's the same vector, go right 2, up 3. It just has different initial and terminal points. But all of these are going right 2, up 3, right 2, up 3, right 2, up 3, right 2, up 3, because the vector is 2, 3 in component form. Magnitude of a vector. So magnitude, like I said before, magnitude is the length. If you're looking at a triangle, you have an x and a y component. Guess what? You're doing the Pythagorean theorem. The magnitude is simply doing the Pythagorean theorem. If you were to sketch this vector, you would say go right 2, down 3. The vector that you're actually talking about is this guy. But what I want the magnitude, I'm going to say, okay, it's 2 and 3. It doesn't matter if it's negative or positive. It's a length. So 2 squared plus 3 squared is 4 plus 9 is 13. So the magnitude will be the square root of 13. All you got to do is Pythagorean theorem. You just need to know what they're asking, basically. They're just asking you to do the Pythagorean theorem, find the length of the vector. If you went right 5 and up none, so right 5, up none, the length would be 5. The magnitude of v, which we write in absolute values, is 5. And last thing, 3/5, 4/5. So if I go right 3/5 and up 4/5, what is the length of this diagonal? This is 3/5. This is 4/5. I'm pretty sure it's going to be 5/5, but let's actually work it out. 3/5 squared plus 4/5 squared is 9/25 plus 16/25, which is 25/25, which, hey, that's 1. So we call that a unit vector. If you have 9 plus 16, you get 25/25, and 25 over 25 is 1. I think of this as a 3, 4, 5 triangle. It's a 3, 4, 5. It's just, it's out of 5. 3/5, 4/5, 5/5. 5/5 is 1 whole. It's the same ratio. And last thing we might have to do is perform some algebraic operations. So if it says add these two vectors together, what we're saying here basically is if I say go right a certain amount for the first vector and right a certain amount for the second vector, you can just add them together and say go right that much. So if you have to go right 2 and left 1, at the end of the day, you will end up going 2 plus -1, you will go right 1. If you went right 2 and then left 1, you would end up, the outcome would be you went to the right 1. If you go down 3 and up 2, at the end of the day, you're going down 1. So you're just adding 2 plus -1 is 1, -3 plus 2 is -1. But if you subtract 2 minus -1 would be 3, and -3 minus 2 would be -5. Oops, hang on, -5. -3 minus 2 more is -5. If you're subtracting, you just got to make sure you're careful here because we're talking about subtracting a negative. If you multiply by a number, that's called a scalar. 2 is a scalar. You multiply a vector times a scalar. 2 times you just double it, say do it twice. So 4, -6 would be 2 times this vector. -3 times v. -3 times -1 is +3, and -3 times 2 is -6. Now these are components, so they're using the less than greater than signs. 2 times u, well, let's do that first. 2 times u would be 4, -6. And 3 times v would be -3, +6. Now if I add them together, 4 plus -3 is 1, and -6 plus +6 is 0. So the outcome at the end of the day is just like saying go to the right 1. So that's it for the first part of vectors. You've got magnitude, you've got direction, you've got some operations to do. Go ahead and get your checkpoint done, and then we'll talk a little bit more about vectors.